Hello and welcome to CCAG's public meeting for June 2023. To use the expression of CCAG's Antarctica expert, Professor Nerilie Abram, something mind-blowing is happening right now in the most southerly region of our planet. As winter falls on Antarctica, the vast wilderness should now be engulfed by ice, but not this year. Antarctica is currently experiencing the lowest levels of sea ice ever recorded at this time of year. In fact, the amount of sea ice in the region is 2.3 million square kilometers below average levels seen between 1981 and 2010. To put that in perspective, that is 9 times the size of Britain. So what are the implications of this massive reduction in the extent of Antarctic sea ice? And how should the world respond? I'd like to welcome Professor Nerilie Abram, paleoclimate scientist and expert on the climate of Antarctica, to shed more light on this topic for us. Also, a warm welcome to our other CCAG members, Sir David King, Dr. Fatima Denton, and Gustavo Alves Lederman, and to our guests, Senior Research Scientist at the University of Colorado, Ted Scambos, and Sea Scientist at the Australian Antarctic Program, Dr. Petra Heil. Nerilie, it's really great to have you here to speak to us on this topic, given your expertise in the field. And I believe you've got some slides to present on emerging Antarctic tipping points. So I'll hand over to you to tell us a little bit more about this and your recent expedition to Antarctica. Nerilie.
Thanks very much, Ade. Can I just check that you're seeing those slides all right?
Yep, I've got them. I can see them.
Excellent. Thank you very much. It's great to be here today and to have a CCAG meeting focused on Antarctica. It's certainly a topic that's very close to my heart. And I think that there's a lot of concerning things that we're seeing happening in Antarctica. And I'd like to touch on just a few of those today. So one of the things that we're concerned about as the climate warms are these tipping points in the climate system. So these are where we see parts of the climate system change very rapidly and potentially irreversibly when we pass certain thresholds in terms of the level of warming. Now, one of the tipping points that we hear a lot about is the loss of Arctic sea ice. And there's been a long-term decline in Arctic sea ice over the last 30 years. It's having major consequences, particularly in the Northern Hemisphere. It's one of the reasons why we see the amplified warming over the Arctic region. But this year in particular, we're seeing some really extreme anomalies in Antarctic sea ice. And so this is a couple of figures based on data from the National Snow and Ice Data Center. And so a plot here that's made by Zach Leib. And this is showing Antarctic sea ice anomalies relative to the time of year. And so you can see in that red curve where 2023 is sitting, and it's well outside of anything that we've ever experienced for this time of year. And the magnitude of the sea ice anomaly that we're looking at the moment is also, as of just the last couple of days, it's become the strongest that we've ever seen. When we look at what that looks like around Antarctica, what we can see is that almost everywhere around Antarctica, the sea ice is well below the extent that it would normally reach. So on that plot on the right-hand side there, the orange line is where we would normally expect sea ice to be sitting for this time of year, and the white is where we can see sea ice. And there's some areas along the Antarctic Peninsula where we have virtually no sea ice has formed yet this year. One of the interesting things about this year is the timing of when that sea ice anomaly is showing up. And what it's really showing is that this year in the autumn, when sea ice would normally be growing very quickly around Antarctica, we do have sea ice growing, but it's growing at a much slower rate than what we would normally see at this time of year. So that's really worrying in terms of where we're actually going to end up with in terms of sea ice when we get to the winter peak, and then if we have a much lower sea ice extent by the time we get to winter, then what does that mean once we get to that rapid decline in sea ice that we see going into the summer? So in terms of the long-term context, this is just showing those Antarctic sea ice area anomalies over the last, since about the late 1970s as an annual anomaly. And what we can see is that there's a lot of year-to-year variability in sea ice, but since about 2014, Antarctic sea ice has had a really rapid decline. So about 2 million square kilometres of sea ice has been lost in the last decade since that time. And just to put that in context, this is the same plot for the Arctic sea ice area. And so what we can see is that if we're looking even over the last 30 years, the Arctic sea ice has been less than what the Antarctic has lost just over the last decade. So the speed at which we're seeing Antarctic sea ice now start to decline is just off the scale in terms of both what we've experienced since this historical record began, and also in the context of the sea ice changes that we've been seeing in the Arctic. Those sea ice changes have a lot of implications. The sea ice is important for habitat. It's used in terms of a lot of the logistics that happens around actually getting science into Antarctica. A lot of nations use the sea ice as a platform to actually get to access their stations and get onto the continent. It has implications for the interaction between the ocean and the atmosphere, and a whole range of other areas where sea ice is really important for the climate system. It also has that direct effect in terms of the white sea ice reflecting the Earth's energy back into space. And when we change that white surface into the darker ocean surface, that has the potential to allow further warming to happen. So one of the other tipping points that we often hear about is around the North Atlantic and how climate warming has the potential to disrupt the overturning into the deep ocean through that meridional overturning circulation up in the Arctic. Antarctica is also really important for the deep ocean circulation. It's actually the densest waters on Earth are formed in Antarctica. And this is a lovely animation that comes from the National Computational Infrastructure in Australia and some of the ocean and sea ice modelling groups within Australia. And what this is showing are these enormous underwater waterfalls you can think of, where around the continent of Antarctica, we form really, really cold and dense water. And that dense water forms on the shelf. And because it's so heavy, it's very cold, it's very salty, and it falls to the very deepest levels of the ocean, and then from there flows out across the world. And that is really important for the way that we move heat around the planet. It's important for moving oxygen into the deep ocean. It's important for the way that we cycle nutrients through the ocean, which are important for supporting ecosystems. So this is something that happens around Antarctica that has global consequences. Now, there are a few parts of Antarctica that are particularly important for the formation of this bottom water, particularly around the Weddell Sea, in the Ross Sea, and some of these areas around coastal Antarctica. And there's a couple of recent studies that have come out just in the last month or two, which have shown that Antarctic bottom water, it's something that has been very difficult for us to actually measure and to monitor how it's changing. But there are these two independent studies that have both come out with the conclusion in the last few weeks, showing that since 1992, there's been around about a 30% reduction in that formation of Antarctic bottom water. So that's a huge decline in something that's really a fundamental part of how our oceans and climate operate. And paired with that, there's also been this recent study looking into how we expect Antarctic bottom water to change moving into the future. And these are very high resolution climate models, so the same models as what that animation was based on, where there's been experiments that have been run based on forcing those with the wind changes, the temperature changes, but also importantly, the meltwater changes. As we're losing ice from the Antarctic continent, we're making the oceans around Antarctica fresher, and that makes it hard to form that really dense water that then goes down to become the bottom water of our oceans. And what this recent study has shown is when you account for all of those processes, what we can expect under a high emissions scenario, that even just within the next few decades, we would expect to be seeing a 42% decline in the formation of Antarctic bottom water. So almost halving the amount of bottom water that's being formed around Antarctica. So that's a scary number in itself. But when we compare that with what we're seeing in terms of the observed changes in Antarctic bottom water, it also suggests that these models are still undercooking in terms of how much of that decline that they're seeing. And so that 42% may actually not be the full story. The other interesting comparison there is to compare that if we do those same experiments looking at the Atlantic meridional overturning in the North Atlantic, under those same experiment design, they see a 19% decline in a 90% slowdown in that overturning circulation by 2050 under those same experimental conditions. So really showing that we haven't focused a lot on Antarctic bottom water and its role in the climate system, but it looks like it's changing fast. There are some big changes potentially ahead in the future, and that's going to be really important in terms of future climate change, and something that we really need to be considering for when we're thinking about climate tipping points. And then the final tipping point that I wanted to touch on tonight was, of course, the ice loss that we see from continental Antarctica. And this is the ice loss that contributes to sea level rise. The West Antarctic ice sheet is an area that has been of concern for a long time, and we're seeing very rapid changes happening there. And so this diagram on the left here is showing our monitoring of ice sheet mass loss since 2003. So the red areas are where we're losing ice from on the continent of Antarctica. And you can see particularly around West Antarctica, those very intense red colors where there is a lot of concern about how quickly that ice is being lost and the potential for passing tipping points, even at warming levels of around 1.5 degrees. And the reason that this area is particularly concerning is because the ice sheet here is sat on ground that sits below sea level. And so the ice sheet is in contact with the ocean. As the ocean warms, it's very effective at melting the bottom of that ice sheet and destabilizing the situation there. And so we can have sort of a runaway situation where when we start to destabilize this ice sheet, then we see changes that become effectively unstoppable. And there's been a lot of work being going on in that West Antarctic area. But one of the things that we're also seeing, as we've developed better understanding of the bedrock topography of Antarctica, we've become more aware of the subglacial basins that are also in East Antarctica. And you can also see on that map on the left, some of those areas of red around the coast of parts of East Antarctica, where we're also seeing signs that ice loss is beginning there. And so we have these worrying signs that the East Antarctic ice sheet, which we previously thought was fairly stable to a modest level of warming, there are some areas of this ice sheet that might also be unstable into the future. Now, if we are able to keep global warming to below 2 degrees, then there are some good signs that substantial ice lost from East Antarctica could be avoided. And that's what's shown on these bars for different centuries. On the left-hand bars are if we keep warming to below 2 degrees. But if we exceed 2 degrees, then we do risk destabilizing parts of the East Antarctic ice sheet as well. And under those scenarios, over the coming centuries, we could be talking about around about 2 to 5 meters of sea level contribution just from East Antarctica. That's not including the West Antarctica and Greenland, which we know are already facing problems even at the current levels of warming. So one of the areas in East Antarctica that we're particularly concerned about is the Denman Glacier. And the reason that we're concerned about that is that this glacier sits on very deep bedrock. It's actually the deepest point of land on a continental area. And so the glacier here is sitting on ground that is 3.5 kilometers below sea level. So it's this huge canyon. And so again, this is one of these unstable situations where as we start to destabilize this system, there is the potential that it could become rapidly unstable and rapidly lose the ice volume that's there. And there's around about 1.5 meters of sea level equivalents of sitting in this Denman Glacier area. And so we don't know a lot about Denman Glacier. It's an area that's been very difficult to get to. There hasn't been a lot of study done on the ground there to really understand that. And so this is part of the research that I'm now involved with. And this is part of a broader campaign across the Australian Antarctic Program to really get a better understanding of Denman Glacier. How does it work? How is it changing? What are the vulnerabilities that we need to be concerned about here? So this is a photo from the Bunga Hills. Over the last summer, so the 2022-2023 summer, a lot of work was put into establishing a base camp at the Bunga Hills, which is just beside Denman Glacier. And so this is going to be the host for a major field campaign happening this coming summer of the 2023-2024 season. There'll be about 40 researchers as part of this effort. And what they'll be doing is to go out and be trying to do a multidisciplinary assessment of this system. So we'll be looking at what the climate is like here. What's the past climate variability? What's the accumulation variability like? What's the geology like? What's the geothermal heat flow? Drilling through the ice shelf to look at what's happening beneath the ice shelf where it's in contact with the ocean. A whole range of studies to really do everything that we can to throw our science at this system and understand where are these tipping points and how worried should we be about this system. So I'm involved in this program. My expertise is through using ice samples to reconstruct climate. So I was down in Antarctica in February of this year. This is our rapid access drilling system. We were testing this for the first time just outside of Casey Station. And this is what we'll be using to go and drill near to Denman Glacier to reconstruct the climate and accumulation history, and then also trying to use this system to get down and access some of the geological material beneath the ice sheet as well. So I'm going to leave it there. I know we've got some experts with us as well through Ted and Petra, and it'll be great to hear their perspectives as well in terms of Antarctica, and I'm looking forward to our discussion.
Professor Nerilie Abram, thank you so much. That was utterly fascinating. Really educational, but also scary. And before we move on, I just want to give a mention out to people who are watching on YouTube. We're currently having some problems with our YouTube feed, which we're trying to fix, but we are live on Twitter. So if you're struggling to watch us on YouTube, head to Twitter and we're there live and you'll be able to get us crystal clear. Nerilie, back to you. As I was saying, thank you so much for that. Just a quick question from me. Taking off your scientist hat and just as an everyday person, you know, how worrying is what you've seen in the Antarctic for you? You know, what does it bring up emotionally when you see this ice loss?
Yeah, that's a tough question. I mean, Antarctica is a place that I love, but it's also a place that has enormous impacts across the planet, even if we don't recognize necessarily in our day-to-day lives how important Antarctica is for us. But I think that one of the things that really sort of astounds me are those moments that we have where you start to see data and you look at it and you go, wow, this problem is even worse than I thought. And that's the kind of emotion that I had when I saw that study that came out a couple of months ago, looking at those the projections of the slowdown of Antarctic bottom water. It was one of those things that scientifically we knew was possible, but actually sort of seeing the magnitude and the rate at which that might be happening, that's the emotion associated with that, is one of, I guess, shock as a scientist that, yes, we knew it was bad, but it's even worse than we thought. And seeing those Antarctic sea ice anomalies is something similar. And I think the Antarctic sea ice example is an interesting one, because for quite a few years, we were, as scientists, trying to understand why Antarctic sea ice wasn't declining, when all of our projections said that in a warming world, we expect that Antarctica is going to lose sea ice, but in our observations, we couldn't see that. And part of that, I think, is because we've had very short records, and if we have longer term records like the ones that we can develop from ice cores, then we do start to see evidence that there has been a long-term decline in sea ice. But then what we've seen now that sea ice decline has really kicked in, just astounding at the speed at which those changes can happen.
Yeah. No, I mean, thank you once again so much for that. And it's so important that we get the reality of this across, not just the science behind it, but the reality of how it impacts us and how it makes us feel. This is our planet after all. I am going to head over and speak to our first guest of the day. And we're lucky enough to be joined by a number of experts in this field. So first of all, I'm going to hand over to Ted Scambos. Ted, thanks so much for joining us here today on your first CCAG meeting. Welcome, Ted. First of all, could you give us some of your thoughts on what we've just heard from Nerilie, and then tell us a little bit about yourself before giving us your question for our CCAG panel?
Sure. Hi, everyone. I'm Ted Scambos. I work at the University of Colorado in Boulder. And I've been there for about 30 years, working with remote sensing data and also going to the field in Antarctica dozens of times, actually, on ships and on various parts of the continent. Nerilie's presentation was a fantastic summary of the problems that we're seeing emerge in Antarctica as it responds to climate change, both a warming ocean, particularly at depth, and then changes in the sea ice, where it's potentially driven by subtle changes in the near surface ocean in that region. I guess the main things that I'm taking from what Nerilie showed us is, as she pointed out, the astonishing pace of sea ice reduction relative to where it should be for this time of year, and set against the past variability, which I think confused us a little bit about whether or not Antarctica was going to respond to climate change. It's definitely catching up very quickly in terms of what we thought might be happening. Understanding exactly what the causes are, I think, is really important. But perhaps more important are the potential impacts of greatly reduced sea ice surrounding the continent of Antarctica. And I guess that's my first question. First question would actually be, there were earlier signs of retreat in 2016, but this looks and feels different, this retreat that's happened in 2022 and 2023. And I was wondering if Nerilie, or perhaps some of the other experts here, had an idea about what those differences are between 2016 and now.
Okay, thanks for that, Ted. Nerilie, perhaps you want to pick up on that, on the question, the differences between the sea ice in 2023 versus 2016.
Yeah, I think it's a really interesting question. There's a huge amount of research to do on this. I think one of the things that's interesting, particularly, is the time of year. When normally at this time of year, there's actually not much variability between the years in terms of where sea ice is going. So to have a year where the sea ice just isn't forming the way that it should be forming is quite remarkable. And that, I think that's very different to 2016, where it was really sort of a really low summer minimum in sea ice that really stood out there. One of the things that I think is quite interesting is to pull up a sea surface temperature map at the moment, and really the only area of Antarctica where the sea ice is sort of where it should be, or a little bit sort of further out than where it would normally sit at this time of year, is an area where there's sort of cooler than usual sea surface temperatures. And so I do wonder to what extent what we're seeing in Antarctica may actually be tied in with what we're seeing across the global ocean. And there have been a number of images recently about just how off the charts the global ocean temperatures are. And we're seeing huge marine heat waves, particularly in the North Atlantic at the moment, but just seeing the amount of heat that is in the ocean. And I do wonder if that's what we're seeing playing out in Antarctica at the moment. I wonder if Petra might also have some thoughts on this as well, coming from somebody who spends a lot of time monitoring sea ice.
Yes, Petra, we'd love you to chip in on this as well.
Yes, thanks. Thanks, Nerilie. That was a magnificent presentation and really inclusive of all the components. So to the question, I think it's, as Nerilie pointed out, you see the warming, especially near the surface, also in the Southern Ocean part. So it's really important to understand that the warming affects the sea ice from underneath, but also delays the formation rates in that active autumnal and vinternal sea ice growth zone. But on top of that, and as part of this coupled ocean ice atmosphere system, we also have seen the typical wind directions to change. And so it's basically driven and encapsulated in the name polar vortex. So that has pulled over the continent much further than in previous years. And so with that, we see actually a dynamic push of the existing sea ice, and as it forms towards the continent in large parts, but then across the whole under ice area, we have this too warm signal. As Nerilie said, if someone looks at a sea surface temperature maps, they're predominantly telling us we are in a state of warm anomaly. And so together they just enforce themselves at the moment and delay this, this autumnal and winter growth this season, which, as Ted pointed out, is very different to what we encountered in earlier years.
Thank you so much. That was Dr. Professor Heil, sea ice scientist at the Australian Antarctic Program. Now, we've heard the science side of it. We've heard how it works. It's in the scientific way. But how does this all impact on us as humans? You know, I'd like to hear a little bit about that from Sir David King. You know, what will be the impacts of, you know, the sea levels rising, and and perhaps you could tell us a little bit about the impact of the overturning current and how that will change the way the planet works as well.
The most important thing, Ade, in terms of impact on human beings is, of course, sea level rise. What we're hearing about is a really rather frightening new analysis of the extent of sea level rise due to melting of ice on land in the Antarctic area. And of course, if you lose sea ice, which is protecting the ice on land, it is much more likely that we'll lose the ice on land more quickly. And sea level rises that are predicted by the IPCC of up to 1 meter by the end of the century, these will have to be re-evaluated in the light of these results, but also in the light of what we now know is happening in the Arctic Circle region. So the Arctic Circle region as a whole is now heating up at about 4.3, 4.5 times the rate of the average for the whole planet. And what we're seeing is I believe, and I think this is what Nerilie is saying, that this is the global ocean impacting all together across not only the North Pole region, but also the South Pole region. And we come to that critically important overturning current, which is the way in which the Atlantic Ocean contributes to distributing heat from the equatorial region into the polar regions, and the role of the Antarctic, that very dense water that Nerilie's been talking about, is a critical part of that overturning current. Now, many of the scientific analyses indicate that the overturning current is likely still to be operating much as it is now for the next 50, 60 years. Even that now, I believe, will have to be reevaluated. None of this is good news for humanity, is good news for the planet, is good news for the biodiversity of the planet. All of this is really now having to be reevaluated. We are operating under a condition where we now understand the critical importance the poles have been playing in the weather systems of the world. And as those weather systems change, and we are experiencing these all the time now, extreme weather events occurring around the world, driven by what we're talking about, this is only going to really play a critical role into the future. Now, I do have, Ade, a few questions to ask the experts, because this is not my expertise area. So I'm interested to know what is happening in 2022-23 looks completely anomalous. What we've seen, and Nerilie showed that graph with increased sea ice actually occurring over the last 10, 15 years. And now we've got this sudden decrease, 2016, but followed by this even further decrease this year. Why this anomalous behavior? Why is it happening so quickly? And is this really driven by what I'm now talking about, those overturning currents? Or is there some other factor that might disappear? Is there some potential good news? Now, your modeling that you showed, Nerilie, looked very, very challenging. It looked as if the anomalous behavior was that slight increase in sea ice that has occurred previously. And I would like just to broaden the commentary on what we think is driving this very rapid change being observed this year.
Over to you, Nerilie.
Yeah, thanks to David. I think that's spot on in terms of the role that this sort of variability plays, and particularly the challenge that we have when we're first starting to see these signals of human-caused climate change emerging. Separating those out, those trends that we expect to continue into the future from the natural variability of the climate system. And I think that's a great example of that is what we're seeing in sea ice, where we have had that natural variability, which confused us for a long time, where sea ice wasn't declining in the way that we would have expected in a warming world. But yeah, when we take a longer term picture, we start to see that, where if we look over the full 20th century, using the ways that we can reconstruct sea ice, we start to see that, yes, there has been a long-term sea ice decline, even though there was this multi-decadal variability in terms of times where we were losing sea ice and times where we were gaining sea ice. So I think that what we're seeing now is probably a bit of a correction to that. And I would say it's probably analogous to the way that we see global warming playing out, where we have periods of rapid warming, particularly when we move into El Nino type phases, where we're moving at the moment, where we'll start to see lots of record-breaking temperatures, having years that are sort of the hottest on record, as opposed to when we're in sort of a cycle of La Nina type conditions, where we still have that long-term warming going on, but we just mute it a little bit because of the natural way that the climate moves heat into the oceans and out of the oceans. So I think that that's what we're seeing with Antarctica now, is that signal of the long-term change is coming out from the natural variability. And because we've had that natural variability masking it, that's where we see this very rapid response. And we see the same response in terms of global temperatures, where when we move from La Nina into El Nino, we'll have a very rapid acceleration in the warming over that period of time and start to have these record-breaking temperatures. But I'd be really interested in hearing other people's thoughts on that too.
I mean, we haven't got much time left on this question. We'll probably have to move on. But my thoughts are, one of the problems we have is, to really understand what's happening, you need long-term analysis. But the problem we have is we don't have long-term to sort this out. And also one of the things I feel with climate change is what we are doing to the atmosphere, to the climate, is now making things so unpredictable that we are going to be getting all of these analogous results as well, and these things that are up and down completely. So Dave, I can see you have your hand up for one more bit, very quickly before we move on to Petra.
Big one. We in Climate Crisis Advisory Group talk about the 3 R's, and the third R is repair. So my big question to hang over the discussion is, what do we do? Is there anything we can do to stop this awful crisis? So, for example, cooling the Arctic Sea area during the polar summer months, would that impact on the entire Arctic and Antarctic problem?
Wow, I said I was going to move on, but then Dave, you threw that in there. So we just can't leave that hanging, can we? Professor Nerilie, do you want to have a crack at this, and perhaps Ted and Petra as well? We'll throw it out to you guys as the scientists from Antarctica.
Yeah, that certainly, it's a big question. I think one of the real challenges that we have in this space when we talk about Antarctica is that Antarctica is a really hard place to work. It's a hard place to get to, and so trying to even test the ideas as to what sort of tools or technology might we sort of be able to employ to try and buy us some time to get the climate problem under control, and try and sort of save some of these or prevent some of the changes or limit some of the changes. In some parts of the world, there's a whole lot of challenges associated with that, but actually sort of getting to the location to do the work is not one of those challenges. Whereas for Antarctica, even just getting there is a huge undertaking. It's a really difficult place to work. It's expensive. It's challenging in terms of how humans operate in those kind of conditions. So I think that repair, when we're talking about an Antarctic context, is really has a whole lot of extra challenges on it compared to other parts of the world. So I think that our emphasis for Antarctica in particular should be really about avoiding hitting those tipping points by reducing greenhouse gas emissions as quickly as we can.
I was going to chip in there, not as an expert, but just for one of our other R's is reduce, and ultimately that's probably the best we can do at the moment. Look, I'm taking an executive decision. As much as I would love to continue on this question, and Ted, I blame you for this, coming in and bringing in such a humdinger of a question that's forcing us to go on for so long. But let's hear from Petra Heil on your question, and also your thoughts on what's happening in Antarctica.
Yeah, thanks. So in interest of time, I won't introduce much, but looping back to what we said before, and I guess the other side of the coin, I believe that geoengineering or climate engineering is not something that we humans should should embrace to do. There have been some recent theoretical studies. For example, there was a proposal to flood the Arctic Ocean with white glass spheres that would then reduce the albedo and reflect the incoming shortwaves to cool it via the radiation balance. And colleagues of mine have worked and researched it very intensively and refuted that they've shown that it's not a way forward for us. So my question then is, Nerilie and perhaps the committee, what do you see are the tangible instruments at national and more importantly international level to effectively avert the imminent climate disaster, which is linked to this current decrease of the sea ice in the Antarctic? So asking, instead of some science solution, what can the governments do and the people in charge?
Yes, I think I'll go to, thank you so much for that, Petra. I think I'll go to Professor Lorraine Whitmarsh first, just to hear what you think in terms of, one, what governments can do, but that sort of also the social impact it has. How is that going to impact us as people, you know, in our social lives? And then we'll go to Sir David on this as well.
Yeah, I mean, I think what we've already heard is that the climate is already impacting us, and it's likely to be impacting us even more. If we're going to be seriously addressing these risks, as Nerilie said, we need to radically reduce our emissions. So we need to reduce emissions, and we need to do that much quicker than we're currently doing that. And that will have impacts on people. That will involve people at all levels, from national decision makers and governments down to kind of regional, local levels, and individuals. Everybody will have to play a significant part. And so that means changing lifestyles. It means working and living differently, and in ways that potentially can improve our quality of life. It's worth adding. In terms of the specifics, I think, you know, the IPCC and others have been clear about some of the sorts of things that we're going to need to do, but at the very least, it means not investing in fossil fuels. It means completely moving away from fossil fuels to renewable and low carbon energy sources. It means potentially designing towns and cities differently in ways that can support active travel and public transport over cars. It's about investing in innovation and technology in lots of different areas, but it's also about reducing demand for lots of different sort of areas of our lives: travel, diet, consumption, energy use, water use, and so on. And so that means involving people and having policies to support people to change their behaviour. So in the UK, for example, yesterday, the Climate Change Committee just published their annual progress report on how we're doing in the UK to meet our carbon targets. And they concluded that we're way off where we need to be, and we need to accelerate climate action by 4 times the speed at which we're going at the moment. We are way off where we need to be. And moreover, we need to place a much greater emphasis on the role that people play, behaviour change, tackling demand, so that it isn't just about energy supply. That's very important, but it is also about how much energy and resources that we're using as well. So there's an enormous way to go. Everybody needs to be involved. And I think it's quite clear what some of those policies need to look like, but we need to bring people with us.
Thank you so much for that, Professor Lorraine Whitmarsh. So, David, your thoughts on the tools that we could use, you know, to make these changes?
I think there are 2 factors that haven't been discussed. Well, one has a bit. One is we, I believe, have put in an excess amount of greenhouse gases into the atmosphere already. This is driving what is happening at the 2 poles, and what's happening at the 2 poles, as we've heard, will impact the entire planet. So I don't feel too satisfied that 1.5 degrees centigrade average for the whole planet is fine, because I know it would keep the impacts lower, but nevertheless, where we are today looks exceptionally dangerous. And we're at 1.3 degrees centigrade above the pre-industrial level as a global average. But we also know that various parts of the planet, even this year, have exceeded that 1.5 degrees centigrade target, and not just the Arctic Circle region. So greenhouse gas removal at scale becomes an important target, in addition to that reduction in emissions. Reduction in emissions, without that, frankly, we're cooked and we might as well sit back and enjoy life. But if we can remove excess greenhouse gases, bring the level down, very few people add in methane properly. 425 parts per million of carbon dioxide, add in methane properly, we're in excess of 550 parts per million in the atmosphere of greenhouse gases. And the prehistoric level, 270. So we've virtually doubled the amount of material in the atmosphere that's capturing heat. That's a big, big problem. But the third thing is, both of these things, reducing emissions, even if every country really did what it should do, is going to take a long time. And I mean 20, 30 years minimum. And equally, whatever we do to remove greenhouse gases, that's going to take a long time to reach a good, stable level. And we need to buy time. So we do need, I'm afraid, to look at refreezing the Arctic, for example. So I totally agree with what Petra said. I don't believe the silica balls are going to make a big difference at all. You just can't do it extensively enough. But I do think we need to look much more closely at, for example, marine cloud brightening, and that's what we here in Cambridge are doing. So I think these objectives are all very ambitious, they're all very expensive, but the challenges from rising sea levels, rising temperatures that will otherwise be delivered by what we've been talking about today are such that loss and damage is going to exceed $1 trillion a year before we go too far. So I think the challenges are enormous, but we can set out a comprehensive program of action. The problem is, which government leaders are listening to us? And we really need to get the message from this meeting into every major government leader in the world to just spell out the dangers of inaction.
Yeah, I think that's a really, really great call to action there, Sir David King. You know, if you're watching, whether you're watching on YouTube or on Twitter, you know, record clips of this, get this out, post this out on your Twitter account, on your social media accounts. This is so important. This is the future of humanity that we're trying to talk about here. Professor Nerilie Abram, I saw you had your hand up there. Did you want to chip in here?
I just wanted to just add one extra comment in response to Petra's question about those, what can we actually do? What are those tangible instruments? And I think that for Antarctica, we need to realize that it's a place that has power in terms of a narrative, in terms of capturing people's attention. And so as dramatic and as worrying as these changes are that we're seeing in the Antarctic, I think that we should be using those as ways to try and build that action that needs to be from the ground up, so that we're getting action at the individual level, local level, being able to communicate that people want governments to be taking action. And so anything that we can use, and I think that Antarctica is a great example because it does have such powerful imagery. It's a place of wonder. And I know that I'm biased when I say that, but I think that it's something that we should use those terrible changes and dramatic changes that we're seeing there to really try and make as much inroads as we can on that public action to drive greenhouse gas emission reductions.
Thank you so much, Nerilie. I mean, the storytelling is so important. That's how we connect with each other, is by telling stories. And I totally agree with you about the sense of wonderment that Antarctica brings, both the poles bring to us as humans. Just quickly before we move on, I want to go back to you, Professor Lorraine Whitmarsh, and just talk about just briefly on the social science of, you know, many people, one, Nerilie pointed out, there is a disconnect in terms of how the public seem to want action, but the action that the governments are taking do not match the feeling of the public. But also there is a swathe of the public that are worried that in order to make these changes that we need, that they're going to have to take a step backwards in their lives. And that creates a sort of fear in them.
Yeah, I think that's a really good point. I think what we know from lots of polling and other sorts of evidence from many different countries is that often the public is ahead of governments in terms of their concern about climate change, their calls for action, their willingness to play a part. But on the other hand, they also experience difficulties in playing their part. They find it expensive, inconvenient, costly in lots of different ways to change their behavior, change their lifestyles. And therefore, lots of reports have shown that if you do want people to play their part, change their behavior, reduce demand, for example, you need policy instruments that enable them to do that. And that could be regulation to ban the most polluting products or services. It can be economic measures to reduce the cost of low carbon products and increase the cost of high carbon products, for example, changing infrastructure, investing in innovation and solutions, and so on. So government absolutely needs to remove the barriers to behaviour change to enable people to play their role. When you present different sorts of climate change policies to the public, very often they're broadly supportive of them, but on the proviso that it will not massively cost them lots of money, that it will not, and in many cases people are already feeling the pinch with cost of living crisis and other things. So we need to make it affordable for people to do these, to install heat pumps and other sorts of solutions for them to change their behaviour in the ways that we need them to. So government need to play a critical role, as well as businesses. They need to be involved in supporting these solutions and making them more available. But government really needs to be driving this to enable people to play their part, because at the moment people see they want to do the right thing, but they find it very difficult.
Whether we agree or not with our governments, they are still a very powerful instrument and they need to play their parts. Thank you so much for that to our panel. Before we close, I'm also quite keen to hear from Gustavo Lederman. And it's not just Antarctica that's at risk. The grim reality is that we are on the edge of a number of environmental tipping points across the globe. Now, new data has just been released showing that deforestation levels have continued to increase despite pledges made at COP26. So could you talk to us briefly, we haven't got that long, but about the level of deforestation we're seeing and the cumulative effects of this wide-ranging damage to the world's ecosystems from sea, ice and rainforest? Gustavo.
Yes, thank you. When we think about the ecosystems related to rainforests, there are at least two kinds of tipping points that we are going to face if deforestation and the GHG emissions continue to rise. One of them is related. In real life, they are related, and but just for us to think what to do, it's interesting to think of them separately. And one of them is just related to deforestation itself. There is a tipping point. There is a minimum size of the Amazon forest when we think the borders, when they get narrow, you begin to change local climate, and in doing so, we are putting the forest in risk with drier borders that are more vulnerable to fire and the drying of the understory of the forests, and there is a huge impact in terms of evapotranspiration, where the climate view and spiral change, and we'll have less cloud formation and less rain. So the conditions for the forest to maintain the ecosystem will change, and the forest will collapse because of deforestation itself. But we also have a tipping point related to climate. If temperature continues to rise, in a certain point, we will not have the conditions that enabled the forest to be formed. And what happens in a similar kind of way, you will change the rainforest to a kind of a savanna-like ecosystem, and that's also due because of forest fires and drying out of the forest understory and the conditions for the rainforest to persist. One thing I think this collapse of the ecosystem, this is very dangerous also for human systems, because if you have less evapotranspiration, less cloud formation, you don't have rain enough for agriculture, and so for example, in the case of Amazon in south east Brazil, and you have a collapse of the main economic activity from Brazil. Just one more important thing, we do have to stop thinking we can buy some time planting forests and continue to do business as usual with fossil fuels. I'm certainly not saying this to our colleagues, but maybe to the audience who still believe that we can compensate emissions from fossil fuel burning by preserving forests and planting trees, because these ecosystems, they are endangered by climate change itself. So there is a tipping point related to climate, and if we don't stop or if we don't curb our emissions from fossil fuels, we will reach this tipping point, and then we'll be above of the emissions from the forest because of forest fires and dieback of the forest, and from the fossil fuels we didn't stop before.
Thank you, Gustavo Lederman. That was, very, very insightful, and really interesting. But look, we've come towards the end of today's session, and that's sadly all we have time for. But I hope that today's been thought-provoking. Hope today's been thought-provoking. But more importantly, I hope it inspires you all to take action. Remember our motto. We've talked a little bit about it in today's session, which is reduce, repair, and remove. Thank you both thank you to both our guests, and of course our CCAG members, and a big thank you in particular to Professor Nerilie Abram for offering her fascinating insight on today's topic. And to all of you tuning in at home, we're looking forward to our next meeting, but until then, goodbye.